afternoon. Welcome back to IoT Track. With the theory that nothing gets people coming into a room faster than loudspeaker voices, let's get going. Again, I'm Paul Madsen. I'm moderating today's track and then speaking in the third. But first up, we have Robert Brown from Trustonic. Robert will argue that, like every British meal, securing the IoT starts with chips. Sorry.
Paul, thank you. Thank you for inviting me to talk. And thank you, everybody, for joining this session and not going to the other ones. So what I want to talk to you about is the latest device-level security in these devices, because they are connecting to the cloud. Mobiles have got a lot of security technology baked in today. It's coming to the IoT as well, and that can really help with identity and access management. So the talk today is about trusted execution environments and some trends that I'm seeing in the industries that could converge, like fog computing and user-managed access. So first, a message from my sponsor, Trustonic. The company has formed in 2012, but it's a combination of two companies that have been working in securing devices over a number of years. In fact, it started off in 2002, right about the time when Andre was setting up Ping Identity, that some very clever folks at ARM came up with a technology called TrustZone. I wasn't there at the time. I joined ARM in 2005, where I promoted security technologies for mobiles and smart cards. So the technology has been around for a very long time, and Trustonic is a joint venture between ARM and Gemalto, the smart card vendor. What we're about is creating a secured platform in devices that makes it easier for people to access services and have higher value services on their devices and protect applications. We are a global company. We're about 100 people. We're based primarily in the UK and France. We've got offices in South Korea, US and China. We've shipped our technology in over 500 million devices so far, mostly mobiles. We underpin the security of things like Samsung Pay and Samsung Knox, and we're also going into the Internet of Things, and we've won awards for doing so. So I've started looking at the Internet of Things and how our technology can be applied, and I started looking at this around 7 months ago, and I thought I'd put the internet to work for me. And if you hadn't guessed, well, as Paul's already said, I'm from the UK, and that is the map of my commute. It goes around the world's biggest ring road, and it's about 110 miles. And my problem is when I go to the office, because I work from home, it takes me about 2 hours, and my wife gets very worried when I don't say I've arrived. Mostly because when I get to the office, I'm distracted by a coffee machine. So I thought, well, there's got to be an answer to this, and there is. I can set up a geofence, and when my phone goes through that geofence, it can send an email to us, say I've arrived. So I looked at setting up this recipe, and there were a few permissions that it was asking for to make that happen, and it said, don't worry, we'll only ask you to do this once. Just click OK, and well, you can't really read what it says there, but I'll point it out. There's conflicting permissions. One says that it won't delete my email. Another permission says it can delete my email. But more worryingly, it said it wanted to search, read, delete, write emails, and reorder my emails. And this is my email account where all my password resets go. So what's the worst that can happen? Yeah, quite a lot, actually. Somebody could reset an email, reset an account, and then delete that account reset, so I would never know that one of my internet accounts has been compromised. So it didn't really solve the problem. So now I want to talk about what trusted execution environments do in the mobiles today. So if you've got one of these smartphones, you've got a trusted execution environment. So hands up who's got a Samsung Android handset. Great, you've already got a Trustonic trusted environment in there. Now, the history behind this is that, as I said, back in 2002, ARM created a technology called Trustzone. And the problem was that in an apps processor, you want to do some security critical functions sometimes. And doing security critical functions in an operating system is generally not a good idea if that operating system can be compromised. So in the past, they built a security coprocessor, which was very wasteful. It added cost to the chip. It was generally lower performance than the main applications controller. And it drew power as well, so it's not exactly an ideal solution. So the clever folks at ARM came up with an idea of making the main apps processor run in a secured mode. So separating off a secured area and running your security functions at the full speed of the apps processor, and that's called Trustzone. So it adds very little cost and it's very fast. Now the software view of that hardware is that you've got a very strong hardware separation firewall between two operating environments. On the left-hand side, which is underrepresented by the size of the boxes, is your main operating system and kernel. That can have many millions of lines of code and many vulnerabilities, as we know. There is no such thing as a finished operating system. There's always updates, and there's always going to be more vulnerabilities that are found. So what the Trustzone technology does is hardware separates a dedicated secure runtime environment. That's called the Trusted Execution Environment. Now, that Trusted Execution Environment is running on the same chip as the main operating system. So it also has access to all of the peripherals that the main operating system has access to. We can connect into things like the memory, the user interfaces, the radio interfaces, secure elements. And we could also run software in there. So it's more than just something like a TPM where there's some security functions. You can run an application in that hardware firewalled sandbox. So that's where you would run your security critical code. The way you talk to a trusted execution environment is you treat it like a peripheral. You talk to a driver in your operating system, pass messages to your trusted environment and your trusted application. Your trusted application will perform whatever function you've asked it to, and then it will hand a message back. The private keys that are used in that operation never leave the trusted execution environment. So we have an SDK that enables people to build trusted applications and make use of this trusted environment in those handsets. And we've got about 80 partners that are building applications in payments, content protection, identity, authentication, enterprise security. We're always looking for more companies that are going to be using the technology to protect their services. We won an award for doing this, and we came away from Mobile World Congress with a GLOMO award from the GSMA. The judges said that nobody should be selling a connected device, not just a mobile, a connected device without a trusted execution environment. So the Trustonic platform enables device makers to deliver secured platforms. So what does it protect in the mobile today? Fingerprint matching. There are a couple of ways of implementing a fingerprint matching system in a device. One of them is put a sensor plus processor on the device. Generally, that processor embedded in the sensor is slow, costly, and it's not an ideal solution. You could put the sensor directly into the applications processor, run software in the operating system. There you compromise security, but you get speed. If you do that in a trusted environment, you get speed, and you get security, and you get low cost. So it's a perfect mix. And most handsets today that have a fingerprint sensor are using the trusted environment to do fingerprint matching against templates. One of the neat features of the Galaxy S6 and the S7 is a trusted user interface. So we can capture inputs from the touchscreen controller directly into the trusted environment. So we can do pin capture and transaction signing. We can do authentication. We can store session keys. The Symantec VIP application on the Google Play Store will inspect the device, if it's got a trusted execution environment, and then it will use it if it has found a trusted environment on the device. In Google Android, there is Gatekeeper and Key Store, and those functions need protection from a trusted environment. That's part of the spec, and that's done in our trusted environment on those Android handsets. We can protect policies, such as set up in Samsung Knox's environment. And we can also protect outputs, so radio interfaces like an interface for Samsung Pay, or interfaces to screens, or even the device screen itself. We can put information on a screen that can't be tampered with, can't be intercepted by the operating system or any malware that's infected the operating system. So onto the Internet of Things, or actually, is it putting the Internet in things? So my definition of what is an Internet thing, well, it's a bit like a mobile. It has inputs, it has outputs, it has comms, and it has processing. This is a module that Samsung produces. This is the Samsung Arctic. It's the beating heart of a smartphone that's been ripped out and ready to transplant into anything else. So it could be going into a car or a fridge or home gateway, anything. That has the technology built in from the mobile, and all the security technology baked in from the mobile and ready to use in an Internet thing device. So will they need protecting? Well, yes, of course they will, because these Internet things are going to be interacting with the physical world. It's not just about sensing, it's about interacting as well. A lot of these Internet things may have outputs and cause some effect to happen in the physical world. A connected car is a 2-ton Internet thing. That can be dangerous if it goes wrong. So yes, we should be putting the best protections in Internet things that we've got in mobile, for sure, because the damage that can be done when they break can be much greater. Will these things get malware infections? Of course they will, because the Internet's going to be inside them. And that's why we've got the Trusted Execution Environment in the Arctic module. Where will the apps come from? Well, look at what Canonical's doing. They're building an app store for Internet thing devices. So this idea that you can start adding apps to IoT devices is coming. This is a good thing, because it means that users will be able to customize their devices to do what they want IoT to do for them. So it's going to be essential for securing high availability services and enhancing our privacy. So the problem with the cloud at the moment, as I see it, is that a lot of these Internet things connect only to one cloud service, the device manufacturers that created them. And that creates a silo of data. And as soon as your data comes off your device and goes into that cloud, you've effectively lost control of it, because you're relying on somebody else to have done a very good job of protecting your data. And you have no means of knowing how good a job they've done. A lot of that data can also be stored in what Bruce Schneier says are toxic data stockpiles. Personally identifiable information attached to that data that can be used against us. So what could be the answer to this? Well, what if we could protect the data before it leaves our vicinity and gets to the cloud? What if we could do a lot more processing at the edge of the network in a gateway type device, where we can put some controls and protection around the data before it gets to the cloud. And then we can pick and choose what data gets sent where. We can make the data anonymous if we want. We can stop storing all this data centrally and move keys closer to the end user's devices and protect our data in a more distributed way. So there's a few examples of hubs that have been around, and you've read the internet blogs about the guys who are up in arms about their Revolve hub service being killed off. Maybe that was killed off because it didn't give enough data to its masters. Then we've got other hub manufacturers that are building propositions where here, convenience and privacy is the order of the day. So I was looking at the earlier problem of all this permission setting and permission greed that the geofencing application I was trying to cook up. And I thought, well, surely somebody solved this problem. And I stumbled across this standard called UMA. And I thought, wow, this is really cool. Somebody's thought about this problem, they built a solution, and they built this concept of resource servers and connecting it to OAuth authorization servers and giving the users control and over the permissions of the data that they're sending out. I thought, well, if this is the best technology that's securing the web, why couldn't this be added to a hub? Why couldn't we treat a hub as a resource server under UMA? Then why couldn't we put an authorization server into that hub? And, well, while we're at it, put an authentication server in there as well. We've got the security technology in those devices to protect those resource servers, authorization servers, and authentication servers. It's a trusted execution environment. So putting the trusted execution environment into that hub and protecting that IAM stack in the home, what could we do? Well, let's say that you want to install an app on your hub, and that's asking for access to a particular resource. You have your smartphone, which is your authenticator, and you install the app on your hub. Your client app that goes on the hub asks for access to a particular resource. That may be a front door lock, it may be a camera, it may be a microphone. And your OAuth server will then send an authentication request to your FIDO server in your home hub and say, I need the user to say that this is okay, that this app is actually allowed, and the user's aware that this app is requesting access. So that authentication request can go to your smartphone. You can put in a PIN or biometric and confirm that that transaction is actually what you want to do. This ties in with the concept of consent receipts that is forming around UMA. That could sign a consent receipt, return that authentication message to the FIDO server, confirm to the OAuth server, issue a token to the client app, and the client app can then get access to the resource. So in that flow, what could you do with, say, a medical gateway? Well, let's say Alice has got some medical sensors that she wants to connect to her doctor. Of course, the doctor gets full information of Alice and all their attributes, but there may be some people that also want access to Alice's data. They may be requesting access, and Alice may say, yes, you can have access, but I'm not going to give you my name, so it's pseudonymous. Or she may say, actually, completely anonymous, those market research can only get access to some of her sensors during a certain time of the day. She's got control of who sees what and when. Another aspect of security is availability. You know, the internet does go down. I've got a 80 meg broadband connection at home, but sometimes it's not available. The router resets or something goes wrong. Now, if I've got a smart home and I've got, say, a door lock and a camera on my front door and a microphone, what would be really cool is if I can have an authentication stack in my home hub and an authorization server in there, and set up a small number of users, my family, to be able to walk up to the front door, say a password, and then get in. Now that service, or that function would be really cool, but I'm only going to use it if I know it's going to work every time. If the internet goes down and I can't get into my front door, I'm going to be upset. So would Alice. So in this thinking, I'm thinking if we take the best practice of identity access management in the cloud and bring that down to the edge of the network, there are a few things that we can do, like enhance the user's privacy. We can increase the availability of service and put the users in control. Think of it, what would you want in your home? How would you want it to work? And more importantly, I think the service providers who are building up these toxic stockpiles of data can mitigate that risk. And the GDPR that's coming into force in May 2018 has some really big, scary fines for any breaches of that personally identifiable information. 4% of global revenue. That's potentially very big for some players out here. So, trusted execution environments, secure devices, they're maturing. They've matured in mobile. They're coming to the Internet of Things. I think there's a trend of fog computing, which Cisco calls it, of bringing applications out of the data center and closer to the edge, where you can have better availability and lower latency. And we can protect the applications when they're down at the edge as well. So devices now are more trustworthy than they've ever been. But most users are now accessing services on these mobile devices that have the built-in trust. So what I'm asking is, how can we collaborate as two industries, the trusted execution environment industries and the cloud identity industries, to make services better for all of us? So I'm interested in talking to anybody who's working on an IoT project with a smart hub. Please get in touch, either through the application for Cloud Identity Summit or email. I'll be around for the next couple of days. Thank you very much for your time.
Thank you very much, Robert. That's a very powerful model. Any questions for Robert?
Oh, there's a microphone coming. Behind you, Paul.
Sorry.
Very nice presentation. Can you go back to the flow chart of that authentication? Yeah, this
Yep.
one. I was wondering, so what is the device that has that secure core or secure module running the module? Because I know the phone has that trust environment. So what is the other one?
I'd envision that something like this would be powering a home hub. So that would be an aggregation point. So I call it the home
That's
identity.
the resource server?
Home identity microserver is what I'd call it. So this would be some kind of hub that has multiple radio protocols and connectivity to the internet.
Does it talk to the trust app running on the smartphone, or?
Well, there'll be a trusted app on the smartphone in the authenticator, which in most smartphones today that run FIDO, they make use of the trusted environment. So there's a trusted environment there in the smartphone already, and there'd also be the trusted environment in the home hub.
And that second trusted environment would secure the signing keys that the authorization server would use to mint tokens, to sign tokens, et cetera.
Correct, yeah.
Yeah.
Yep.
I have two questions on this chart. The person that you show, is that an IoT or could be wearables on devices using phone for authentication? That's the first question. The second question, you talk about the IAM for home.
Mm-hmm.
How about, do you have like correlations between IAM for home and IAM for office and vacations, and or correlate, managed together? That's the second question. Thank you.
Okay, so the person there would be the owner of the device that they're connecting into their hub. So there could be another IoT device here, which would be something like a sensor or a door lock. The constellation between this and enterprise identity, well, Paul, I think it's over to you guys at Ping Identity to try and figure out which parts of the identity stack could run in a sort of a micro server versus a full stack IAM solution that an enterprise would run. This would be something much smaller, say for 4 users doing a very limited function.
So to that point, you know, that flow at least does not call for UMA. That's a very basic OAuth flow, right? You're not, this at least wouldn't require the extra pieces that UMA gives us. Other scenarios, maybe, when you're inviting a house guest into your home and you want to authorize that binding, well then UMA starts to become of interest. Thanks again. Oh, one more?
One more.
I can ask after the coffee.
I think we got it.
So going beyond, let's say, a home hub, if we are looking into an industrial gateway, IoT gateway. So in that case, let's say we have the demand for doing some analytics at the edge and other compute-intensive activities. So do you envision that in that case, we use this chip that you are showing here just for IAM functions and have different processing capabilities, or
No,
how does that work?
I mean, this module has a quad-core processor. This one's got an 8-core processor.
Okay.
So yeah, you could do a lot of work with this processor, and that's the same processor running the secured stack.
I see.
So
Yeah, because the whole idea was that they are all running on the same chip, right?
That's
The
right, yeah.
Okay.
Yeah. So if you've got the security technology there, then use it. It's certainly going to help protect against the vulnerabilities when you've got an open source operating system running on that hub.
Mm-hmm. Okay, thank you.
If it's there, use it.
Sure.
Thanks again, Robert.
Thank you, Paul.
Thanks.